Well, here we go. We have some Legos. I have 9 Lego blocks, and what we're going to do is figure out different ways that we can group them. So I'm going to start with, not one actually, let's start with 2. And if I have 2 of them, then I could say, well, I have one group of 2. And I didn't put the word group in there. I didn't put one group of 2. I put 1 and then 2. So it's really like 1 times 2, right? So 1 times 2 gives me 2. So like if I have 1, 2, then I have a 2. I wonder if there's another way I could write this. So in other words, I'm wondering if there's a way I could be like, well, 2 equals 1 times 2. Or I could also say that it's something else. And actually there is another way, but I'm not going to put it on my actual notes. This is just me doodling here. I could say it's 2 times 1. So I could have one group of 2 or 2 groups of 1, and it's the same thing, right? But I'm not going to do this because 1 times 2 and 2 times 1. Same thing, fine. All right, let's move on to 3. So I have 3. And I could say I have one group of 3. And I could also say I have 3 groups of 1. But again, one group of 3 or 3 groups of 1 is going to give me the same product in the end, right? So now the question is there another way I can write this to where I'm saying, oh, 3 is really 1 times 3, or it's something else? Okay, well, let's try to figure it out. Maybe I can have a group of 2, and then, oh, wait, no, I can't have a group of 2 and then another group, because this isn't a complete group of 2, right? If I'm going to group them in 2s, then I have something left over. I don't want to have anything left over. In other words, 3 is 1 times 3, and that's all it can be. So now we'll get to 4. And I know I can do a group of 4. So like if I have 4 Lego pieces, I could say, oh, I'm going to put them in a group of 4. And I could also say that I'm going to put them in 2 groups of 2, right? So I have 2 here and 2 here. And so I could do that. And if I put them in a group of 3, I'm experimenting, just trying to see if I could go over here and say, or 3 times something. I'm wondering, maybe I can. And if I can, then I would do it. But if I have a group of 3, then I have something left over here, and I don't have a complete group of 3. So that's it. We're done. That's all I can do with 4. Let's do 5. 5, let's see, I could have a group of 5. I could have, see, I can't group them in 2s because he's left out. I can't group them in 3s because if I group them in 3s, then I have this group of 3 and then another group that's not completely a 3. So the only option I have, 1 times 5. I mean, I could do a group of 4, but then that guy doesn't have a whole group of 4, right? Let's do 6. Okay, this is going to start looking a little familiar, I think. So 6, I could do a group of 6. Just trying to find ways to group them. Maybe I can group them by 2s. Oh, so maybe 2 groups of 3. Let's count up. So I did a group of 6, 2 groups of 3, or maybe I could do 3 groups of 2, right? So if I do 3 groups of 2, then, well, it's the same as 2 times 3, right? Then a group of 4, no, 5, no, nope, that's all I can do. That's all I can do with 6. Let's do 7. I can do a group of 7, 1 times 7. If I put them in 2s, that's not going to work because I have a remainder. If I put him in 3s, then he's left over. If I put him in 4s, I don't have complete groups of 4. I have one here, but I don't have one here. A group of 5, I have a group of 5, but that one doesn't have 5. A group of 6, but he's left over. So no, that's all I can do. A group of 8. Now, at this point, you're probably kind of bored with the whole process, and you're saying, well, where in the world is he going with this? I'll tell you. You'll see. I could do a group of 8. We can always do 1 times whatever. We could do 2 times 4. I have 2 groups of 4, or 4 groups of 2. I can't group them up by 3s. See, that one doesn't have a complete group of 3. Can group them up by 4s, but then I have 2 times 4, and I'm back where I started. So that's all I can do with 8. And then we'll do 9. So obviously 1 times 9, or maybe, okay, well, let's try 2s. 2, 2, 2. Oh man, he's left over. So no, can't do that. Maybe we can do 3s, a group of 3, another group of 3, another group of 3. Oh, yeah. Okay, 3 times 3. So, or 3 times 3. All right. And 4 won't work, 5 won't work, 6 won't work. So that's it. So now the question is, what patterns do we see? So, we were playing with Legos just to kind of figure out what this is. And I left the number 1 off for a reason, because we're grouping things and you can't group one thing. Some people would argue with that, but I'm going to go with no. So what patterns do you see? And another thing is, what definitions do we need? So let me kind of define it and point out a couple patterns. There are certain numbers like 2, 3, 5, 7 that only have one way of multiplication to get there. Multiplication with just counting numbers. That's all we can do. And so 2, 3, 5, and 7, they're what we call prime. So nothing goes into 2, 3, 5, or 7 evenly. Now, I don't mean even like divisible by 2. I mean even like nothing goes into 2 except 2 times 1. Nothing goes into 3 except 1 times 3. And no matter how much I try, there's no other number that'll divide into 3 that will work without giving me a decimal. So now the question becomes, what other numbers, if we were to keep going and keep playing with Legos all day, what other numbers would I highlight? 10, 11, 12, 13, and where does this end? So we have just kind of explored and found out that there are some numbers that only have one way of writing their multiplication. What are they, and does it ever end? So let's keep going. 10 is 1 times 10, or it could be 2 times 5. And to find the answers to these, we could pull out our multiplication table. See? All right, so we have 1 times 10, right? But if I look for 10 elsewhere, I'll see it here at 10 times 1. That doesn't count. But I also see it at 2 times 5. And I see it at 5 times 2. So if I see a number here more than twice, then it is in the list that I do not highlight. Okay, so 1 times 9, 3 times 3. So 1 times 9 is here and here. 1 times 9 or 9 times 1. 3 times 3 is here. So it happens more than just the ones on the edges. The number 9 appears more than just in this row. It appears out here. And because it does, I don't highlight it. It's not a prime number. So let's write a little bit. Let's say prime numbers. They are numbers that are only divisible by 1 and themselves. And again, the question is, where are they? Which ones are they? And do they go on forever? So here, let's do 11. 11 is 1 times 11. 2 doesn't go into 11. 3 doesn't go into 11. 4 doesn't go into 11. 5 doesn't go into 11. 6 doesn't go into 11. We'll stop there because by that point we'd be kind of going back around. So 11 is prime. And another reason is because I see 11 on my chart, but I see it here and I see it here. That doesn't count. If I see 11 out here beyond 1 times whatever, then 11 is not prime. But in this case, 11 is prime because it doesn't show up elsewhere. So 12, 1 times 12, 2 times 6, 3 times 4. Well, clearly now we're getting into the areas where we have like multiple ways of writing it other than just 2 ways. So this one's not prime. This one is prime. 1 times 13. All right, so again, I wonder what numbers are prime. We're going to find out which ones are.